Hello everyone, in the last video we discussed depth first search in a graph, and in this video we are going to continue with graphs by discussing another very popular concept, a traversal algorithm in graphs, which is BFS. So like DFS, BFS is a building block to several other problems in graphs, and it is one of the most basic concepts in graph. So BFS, like DFS, is another traversal algorithm where in BFS what we do is we completely explore a path and then we go on to the next path. But in case of BFS, what we do is we try to visit all the vertices which are adjacent to the source vertex completely and then go on to the vertices which are slightly more farther than this the adjacent vertices of the source vertex. So we increase the distance by 1 unit in each iteration of this traversal. So let's initially look at how this algorithm works before we go on to the implementation. So let's take an example over here. So consider this graph and its adjacency list given over here. So I have already explained what adjacency list is in the previous video. So if you want to know more about it, you can explore on your own or watch my previous video. So in zero's adjacency list, we have all the elements which are adjacent to it. So for 0, it has 1, 2 and 3 as adjacent elements. So all those elements are there. And for 1, we have adjacent elements as 4, 5 and 0. So we have 4, 5 and 0. And similarly, it is populated with all the other vertices. So now we'll have to initially fix a vertex where we are going to call the breadth first algorithm. So let's say we are starting with 0, and when we are starting with a vertex, when we are exploring a vertex, we'll have to mark it visited so that we don't explore it again. And what we do is, unlike DFS, instead of making recursive calls for each of the vertices, we keep a queue, and in that queue we are going to push all the elements which are adjacent to the current element that we are exploring. So if we are starting with 0, then we'll have all the elements 2, 3 and 1 as the adjacent element of that, and we are going to push it into a queue. So we have 1, 2 and 3 in the queue now. So we'll have to mark it visited as well as we are exploring it, and we take 1 out, and as we take 1 out, we are going to populate the queue with the adjacent elements of that element. So now we have 4 and 5 in the queue, and we are going to mark it visited as well. So 4 and 5, and next we go back to the next element. So we are going to pop the front element in the queue 2 and populate the adjacent element of 2 to the queue. So that will be 6, and we continue on with this process. We take out 3 and add 8 to the queue. We take out 4. There are no more elements in the adjacency list of 4. We already have seen 1. So we go on to 5. No elements for 5 as well. And 6 we have 7. So we push 7. And for 8 we have no other elements. So you will know that we have a certain order in which we are accessing the elements, and that would be the degree of closeness, how close it is to the starting vertex. So first we explore 1, 2 and 3, which is 1 unit away from the starting vertex, and all the other vertices that we see after that would be 2 units away, that is 4, 5, 6 and 8, and then 7 is 3 units away, so it is seen last. So that is exactly the order we get over here. We start with 0, then 1, 2, 3, 4, 5, 6, 8 and then 7. So that is how BFS basically works, and we will need an additional data structure queue for this instead of making recursive calls like DFS. So let's get on with the implementation then. So like I said, let's start by creating a queue. So we can use the inbuilt data structure queue in C++ STL. So I'm gonna make it queue, and then I'm gonna need a map as well. So instead of a map, we can simply use a vector to see if that element is already visited or not. And let's say it has a size of v, and I'm going to initialize it with a value of false, which can also be represented by 0. So I'm going to push the first element, which is 0, into the queue. and I'm also going to mark it visited. Now I'm going to put a while loop which goes until the queue is empty. So I'm going to initialize a variable over here, int x, and give the value of that variable to the top element, which is so we don't have a top in a queue. What we use is friend. So queue dot friend. In stack we have a top, queue we have front and a back, and we are going to pop that element. And once we have done that, we have to simply push it into our answer vector. So we can initialize an answer vector as well. Answer dot push back, and we can simply add the element into our answer vector. And once we have done that, we'll have to push all the elements in the adjacency list of the current element into the queue unless it is visited. Let's get the size in another variable, int n equals, so let's initialize this n here as well. So n would be the size of the adjacency list of the current element. And now we are going to put a for loop to iterate through that adjacency list. And we are going to check if that element is already seen. Visited of adj of, and we mark it as already visited, and then we push it into the queue. And there we go. That's pretty much it actually for the while loop. And once we are done iterating through the while loop, and once this condition evaluates empty, then it means that we have seen all the elements in the graph. So we can simply return the answer vector. So it's adjacency list of x dot size, not v dot size. So let's try and submit it. And there we go. That was breadth first search in a graph, and I'll put the code as well as the question link in the description. You can check it out, and I'll see you guys in the next video. Good night. Goodbye.